Hello everybody and welcome back to a new video. In this video we are going to finish up the module we started last week that deals with architectural woodwork. So your reading for this week is going to be that same ballast reading that you started last week, except this time we'll be going from pages 7 to 16. Alright, so getting started here, we're first going to take a look at architectural paneling. So there's two basic types of architectural wood paneling. The first one that we have is known as stile and rail paneling. This is also sometimes referred to as raised paneling. And this is going to be your traditional wall paneling type, and it's composed of vertical pieces that are called stiles and horizontal pieces that are called rails. And these two pieces together will enclose a panel. Okay, so if we take a look at this image I have here, this is traditional wainscoting. You'll see this in a lot of maybe older houses or even some modern houses that have more of a traditional design aesthetic to them. But this is an example of raised paneling, and if we look at these side pieces here that are going vertically, those vertical pieces are called the stiles, and then these horizontal pieces above and below the panel are what are called the rails. And when they build these, they will basically build the entire panel, or they'll build the frame, which is composed of the rails and the stiles, and then within that they will insert the panel itself. Okay, so the panel is this middle portion, and basically the stiles and rails lock together around that panel and they hold them in place. And then the panel is installed onto the wall, and then they will install additional moldings like the baseboard and the chair rail that sits on top as the cap. All right. Here is some basic terminology that goes along with raised paneling. So as I mentioned, the wainscoting is the portion here toward the bottom that usually only goes up a few feet or so, and then it is capped at the top with a chair rail. At the bottom, the molding running along there, that's going to be your baseboard. Anywhere that the wainscoting and baseboard intersect with door casing, you may have what's known as a plinth here, or a plinth block. Those aren't always there, but in some houses or in some designs, you will have those plinth blocks around the door frames. The portion of paneling above the wainscoting, that's just known as the wall panels. Okay, so here you can see we have wall panels, and they are constructed in the same way as the wainscoting, except they're obviously taller. And this is usually optional if you have wall paneling. Sometimes it'll be just like you see it here on the previous example, where it's just the wainscoting and no panels above it. But sometimes, especially in higher end interiors, you may see full paneling all the way going up the full height of the wall. And then at the top, you're going to have your cornice or crown molding. And that's basically it here for this diagram. So then the second type of paneling that you're going to run into when designing, and this one is going to be probably a lot more common for you guys as designers, is flush paneling. So flush paneling is a type of wall paneling that's used a lot in modern designs or commercial designs especially. So what this is basically is it's a flat smooth surface with edges butted together or joined with a reveal. Okay, and it is built up of thin wood veneers glued to backing panels of particle board or plywood. So here's an example that I found here that I thought illustrated this pretty well. As you can see, this is some sort of a commercial space. Maybe it's like a law office or something, and they have their logo installed upon it, but the entire wall is basically just a series of flush panels that are installed over top of the gypsum behind it. Okay, and the gaps that exist between each of these are a series of small reveals. Okay, so by a reveal, I'm just referring to a small space or a gap that exists between each of the panels. So if you look down here at this little diagram, there are two ways you can join these panels together. So either you have what we're seeing here, which is a reveal, where there's this gap here between the two panels, or you could actually have the panels completely butting up against one another, but then anywhere they touch, they have this little eased edge. So if you see that little sort of divot right there where the two are joining, they will take and route a small radius along the edge of the panels to highlight that joint. Okay, so these are the two ways that you're going to run into whenever you're specifying these to be installed, if you ever use them down the road. But basically, these panels, so as we learned last week, a lot of times to save money, you can use veneers on projects so that you're not using a full solid piece of wood, which could be really expensive, especially if it's a exotic or it's a unique wood species that is meant to look fancy. So in cases like this, you could specify a wood veneer of maybe a fancier type of wood, and then that veneer gets installed over top of a substrate. Maybe the substrate is like MDF or a particle board, or it could be plywood as well, and then those entire panels are installed. All right. So when incorporating wood paneling into a design, there are three different panel veneer matching methods that you can specify. Matching is basically the process of orienting the grain pattern in certain ways to achieve particular looks. Okay. So I'm going to explain this a little bit, but as you can see, this tends to get pretty complex pretty quickly in terms of matching. So these are the following ways that you can match a grain pattern within a single panel. Okay, so these three methods, when I'm showing you these, I'm referring to just one panel of wood. Okay, so first we have to consider how is the wood grain matching within this panel. If you were to look at this panel, you can see the same pattern is being repeated twice. So you can see that wood grain right here and wood grain right here, that's repeated twice. So these were matched in some way within the panel. But then later on, after we do the matching within the panel, we have to consider how the panels match to one another as well. Okay, so that's why this is going to get complicated. But starting off here with just one panel, the first thing we can do is a book match. And a book match is basically where you take the veneer and then you're going to slice it sort of in half and flip it upon itself, sort of like a book. So it's kind of opening like a book. And this produces a symmetrical design. So this is basically what you saw on the previous slide. We have the same grain pattern basically repeated twice, and they're just book matched and then butted up against each other. Okay. The second thing you can do is what's called a slip match, and this is basically where you do the same thing as you're seeing up here, where we are cutting this into 4 separate little panels, I guess you could say. But instead of flipping this back on itself like a book, so we have this symmetry, we're just going to keep them all in the same orientation. Okay. And then you can also do what's called a reverse slip match. And a reverse slip match is basically where you're going to take the second one and you're going to flip it upside down. So you can see this is kind of producing this sort of shape where it's going up and then it's coming back down on itself. But these two I have categorized both basically as the same thing. So they're both the type of slip match, okay? And then the last one is what's known as a random match, and this is where you're going to take random widths of the veneer and also random grain patterns and kind of all put them next to each other to create a bunch of variation, okay? Now, as I said, first we have to consider a single panel. So all three of these three previous methods I showed you were just talking about a single panel. Now we have to consider, after we specify that, how do multiple panels within a design match up to one another? Okay, so here you can see we have 4 panels, just like we're seeing here. So here we have 1, 2, 3, 4, 5 panels. So we have to consider whenever we're installing these, how do we want the installer to orient these so that the grain pattern looks good from panel to panel? Okay, and there's a few different ways they can do that too, and there's actually 3 methods again to choose from. So the first one would be a center match, and this is basically where the pattern is starting in the center and kind of working its way outward, and everything is sort of very symmetrical and consistent. This one, I believe, this is going to be the most expensive option because it takes a lot more work to plan for this and get everything matched and like looking exactly the same and consistent. Then we have a balance match, which is not quite as expensive. It still looks pretty consistent the whole way across, but you may have some breaks in grain consistency as you go from panel to panel. All right, especially on longer runs. And then the last one would be a running match. So this is kind of where you just have a bunch of random widths of the grain pattern all butted up against each other. And you can see with these lines here that are indicated, those are showing the start of new panels of grain. So they're just going to take a bunch of these random widths and kind of put them against each other and then just do a bunch of panels one after the other. And this is going to be the least expensive, but usually it's the least desirable as well, just because a lot of people prefer the symmetrical look that the other 2 options provide. Okay, and then lastly, if this was going to be used within an entire room, so let's say we're not just dealing with a single wall like we saw in that picture I showed you. Let's say we have a full room where we're going to be putting paneling on every wall within the room. You're going to also have to consider how all those walls are lining up in terms of grain pattern too. So this is where this last section here is what that's talking about. So again, there's 3 different ways that an installer can match the grain patterns within the entire room. So if you look at these diagrams here, there's going to be 3 of these diagrams. Basically, we are looking at 3 walls folded out flat, sort of like a cube. So here you can see a corner of the room, and then again, here's the other corner. Okay, so first wall, second wall, third wall. A warehouse match, this is going to be the least expensive matching method. And this is where all of the panels are pre-manufactured, so they're all stock, they're not custom made or anything. And this is going to result in a loss of grain continuity. So as you install these along one wall, as you hit a corner and transition to another wall, in this corner it's very common to have some inconsistency when you're transitioning from one panel to the next. All right. Also, all of the panels within this type of matching scheme are all going to be a consistent width. So you can see all of these are the exact same width as the next. All right, the next one is going to be a sequence match. This one is more expensive than a warehouse match, and all the panels are going to be custom made for the space. Right, so they're actually going in and they're measuring and they're planning it out based on the space. You're not actually just buying something stock that's pre-made like you are with the warehouse method. The grain pattern is going to be fairly continuous except for around openings. So as you can see, the whole way around this room, the grain pattern is pretty consistent. Even in the corners, usually you can get a pretty consistent look as you're transitioning. But then whenever you're hitting these openings like doors and windows, you're going to have seams there, and that is going to cause some lack of consistency between the grain pattern. And also the panel widths in this method may vary. And then the last one, this is going to be the most expensive one. This is known as a blueprint match. And this is where you have a high level of planning going into this, and all the panels are manufactured to precisely fit within the room and line up with every obstruction. So doing it this way, you're going to have no loss in continuity within the grain pattern. And also the panel widths may vary, just like the previous method. So this one's going to be pretty expensive to do, but in really high-end applications, this may be the most desirable method to use. All right. So now we're going to talk about some ways that these panels actually get mounted to the wall. And again, this is only for the flush panels, okay? So there's going to be two common methods for mounting flush panels to the walls. The first method is using wood cleats. So there's going to be diagrams on the next page of these, but I'm just going to talk about them really quickly. This is when you have a panel that is fastened to a horizontal board known as a cleat, and this cleat is then going to sit on top of another cleat that is fastened to the wall. This requires wood blocking to be installed within the wall cavity if you're using metal studs. All right. So then the second method is known as Z-clips, and these function the exact same way as wood cleats, except they use pieces of metal hardware that interlock instead of these wooden boards. And the nice thing about these is they allow the panels to protrude less from the wall you're installing them on. They also require wood blocking to be installed within the cavity if you use metal studs, just like the cleats. So here's what those look like in a section view. Here on the right side is our actual wood flush wood panel. So here's one and here's one. Now here's the cleat method. So you're screwing this piece of wood, this is the cleat, into the back side of the panel. You then have another wood cleat that is going to be screwed into the wall into some sort of a wooden blocking that is within the wall structure. After you have everything screwed together, you're basically taking the panel with the cleat attached to it and you're hoisting it into place and resting it one cleat on top of the other cleat. And you can see the way that these are cut. They're cut at a slight angle. And being cut at this upward angle is going to prevent the wall panel from slipping and falling off the wall surface. So obviously if this was just cut at a perfect 90-degree angle flat and you set one on top of the other, there wouldn't really be anything locking this into place, so it'd be very easy for the panel to just fall off of the wall. So that's why they put this slight angle on the cleats. The other method is the Z-clips. So you can see it's pretty much the exact same setup as you have with the wood cleats, except with the Z-clips, you have these interlocking pieces of metal. So you're going to screw one into the back of the panel, and then the other one you're going to screw into the wood blocking within the wall cavity. And then you're going to lift this one up into place, and you're going to slide it down so that these two clips interlock with one another, and that's actually going to hold it to the wall. But if you take a look at the comparison here, this gap that you are seeing between the back side of the panel and the front side of the gypsum is going to be much smaller than you have when you're using a wood cleat. Okay, so you're going to have about a 1/4 inch gap here, and here you're probably going to have like 3/4 of an inch. So this is nice to just add like a little bit of space within the room. Even though it might not be much, you're going to gain a little bit. And then this is just a diagram showing that Z-clip a little bit better. So this is it in 3D. Here you have your panel. Here is the first Z-clip that is screwed into the back of the panel, and then the other Z-clip that is screwed into the wall. Then you're lifting the panel up and you're placing one Z-clip on top of the other, and this is how they're going to look in section when they're interlocking with one another. All right, now let's talk about trim and molding. So the first type of trim that we have within an interior space is what's known as standing trim. This is trim that can be installed with a single length of wood. Usually this is going to be seen with window and door trim. So basically all that means is whenever we are receiving the trim from a manufacturer and we want to install this trim wherever we're putting it, maybe it's around a door or a window, we don't have to lengthen the trim in any way to get it to fit. Okay, so basically you can just have one piece of wood and it's going to be long enough to go around the door opening with that without adding on to its length with another piece of wood. So if you remember from last week, I talked about different types of wood joints, and one that I mentioned was a scarf joint. And I said you would commonly use a scarf joint on pieces of trim such as baseboards or crown moldings where you're going around a room but maybe the length of the trim just isn't long enough to make it all the way from one end of the wall to the other. So you're going to have to add on to the length by joining another piece of wood to the existing piece. So you would use a scarf joint to butt the two pieces of wood together so that you can extend the trim and make it go all the way around the perimeter. All right, so standing trim is trim that is long enough already, and you don't have to make it longer in any way by adding some sort of a joint and extending it with another piece of wood. Running trim is the opposite. So this is the trim that's like the crown molding and the baseboard, where typically you're not going to be able to get lengths of it from the manufacturer that are long enough to just, cut it and install it. So usually you're going to have to put in special joints like scarf joints or sometimes just butt joining them together to get it long enough to go all the way around the perimeter of the room. All right. Wood molding is available in a wide variety of species and profiles. So when I'm talking about a profile, I'm referring to the cross-section shape of the molding. So if you look down here, this is a bunch of different profiles or shapes of common molding, and these are all pretty much standard shapes that are stock anywhere. So these profiles are usually standard stock. Again, any manufacturer that you're going to go to who makes millwork, they're going to have a catalog of standard profiles you can select from. But you can also specify and create your own custom profiles, okay? So if there was some sort of a custom shape you wanted, they could actually go in and create special blades and knives to custom mill any shape that you really wanted. Okay, so one application where this is particularly useful is if you are working on an old historic building maybe, and it has a bunch of old fancy woodwork. A lot of the times the profiles that were used for that woodwork in that old building will not be in use anymore. So if you were to go to a millwork manufacturer and say, hey, I want you to match this woodwork, typically within their standard catalog of profiles, they would not have a perfect match to what you need to one-to-one match it. So what you can do is you could actually give them a sample of the old woodwork from that building. Maybe you just pop a piece off and you take it into the millwork manufacturer and they look at it and then they can actually custom match that shape, okay? So if you had a piece of baseboard or crown molding and you wanted them to match it, just take that to them and they'll use that to generate a one-to-one perfect match so that any new wood you're putting into the project is going to perfectly match the existing wood. That's something that I actually had to do in my house. So we did a bunch of renovations and moving around walls and things in my house when we were working on it. And when we did that, we ended up needing new baseboard. Well, my house is over 100 years old, and the type of baseboard that we have is about 6 to 8 inches in height. So clearly that's not standard because modern houses have a lot shorter baseboard, and also the profile of it was a bit different as well. So the profile that we have on our baseboard was something when we went to the millwork manufacturer, they said, well, we don't have a profile that matches that. So like I said to you a minute ago, I had to go in and remove a piece of the baseboard from somewhere in the house and take it into them, and then they were able to custom match it. So now anywhere we had to put new baseboard, it now looks exactly the same as the old baseboard, and you wouldn't know. All right. All right, so then the last thing we are going to discuss in this module is types of finishes that can be applied to woodwork. Now, this is probably something you touched on in maybe your furniture design class, but we're just going to run through it here again as it's a part of the reading. So there are several different types of finishes that can be applied to woodwork to protect and enhance it. They are available as both water-based and oil-based solutions. Here are a few of the common finishes. Now the reading goes a lot more in depth on this, and it gets into the sort of chemical makeups of these types of finishes, and also maybe touches on a few more than I am here, but these are the most common types, and also this is the most basic information that you're really going to need to understand about these. So the first one we have is what's known as lacquer. So this is a solution composed of resins that produces a very glossy and durable finish. It's a very common finish for furniture, so if you see a lot of like older style fine furniture, they may have a lacquered finish, and usually the finish is very glossy and it's also very hard and durable. The second one that we have here is what's known as varnish. So this is an oil-based finish that is also very durable. It is appropriate for both interior and exterior applications depending on how it was made. So you're going to have different types of varnishes. You might just have a regular varnish for an interior application, but then for exteriors you may have another type which is known as a spar varnish or a marine varnish, and that's actually what they use on like the decks of boats to protect the decks from water damage and stuff like that. This type of varnish is finish is available in a variety of sheens, and some formulations of it will tend to yellow over time. So as this sits and gets older after it's been applied, over time it may tend to take on this golden or yellowish hue, but some do it more than others. It just depends on how it was formulated. This is a commonly used finish for historic woodwork. So a lot of older buildings and older houses, if you see that they have woodwork that hasn't been painted, usually they were coated with some type of a varnish. All right. And then the last one we have here is polyurethane. So polyurethane is probably going to be the most common type of wood finish you'll run into nowadays. This is available in an oil or a water-based solution, and it is good for interior applications, okay? So this is going to be commonly used for interior furniture and also for flooring. So anytime you have hardwood floors and you're refinishing them, what you're usually going to put on those is some type of a polyurethane. And it's also available in a variety of sheens. So you look at this picture here. Here's an example of a hardwood floor that they have put polyurethane on. And this is probably like a semi-gloss sheen that they have applied to it. All right, and then the final thing we'll talk about is wood stains. So prior to finishing wood, a stain can be applied to alter the wood's color. This could be done purely for aesthetic reasons, or it is also commonly done to make cheaper wood species look like a more expensive wood species. So let's say you had a really fancy type of wood that you wanted to emulate. Maybe it's like a cherry or something. Well, if you had a cheaper wood species, maybe like poplar or something like that, you could get a special stain that's meant to mimic the appearance of cherry or mahogany and apply it to that cheaper wood and actually make it look like it's a more expensive wood species than it is to save some money. Stains are available in oil or water-based formulas. Oil-based formulas have less uniform appearance than water-based formulas. However, a water-based formula will raise the wood grain and an oil-based formula will not. Okay, so that's something to consider. However, I've done projects in the past and I've tended to stick to oil-based just because I like those a little bit better. But usually when you use those, you have to do what's called conditioning the wood, where you're actually putting a special product on it to open up the wood pores so that they will accept the wood stain in a uniform manner. If you don't do that, then like this is saying, the oil-based formula can cause the wood to have a blotchy appearance after you apply the stain to it, and it doesn't look so great. So if you ever do use an oil-based stain for something, before you actually apply it, you want to make sure you've properly conditioned the wood so that it will accept the stain uniformly and not look blotchy or weird. And then something also to note is that stains can be purchased in a wide range of colors and opacities. So you're going to have a range in opacity from transparent all the way to solid. So a transparent stain is going to alter the color, but it's going to preserve all of the grain pattern. So you'll still be able to see the grain showing through, but the color of the wood will just be changed. Semi-transparent will also change the color of the wood, but it will partially mask out the grain pattern, so you can still faintly see it, but it again is being a little bit masked out by the stain. And then the last one is going to be solid, where it's just changing the entire color of the wood, and it's also covering up all the grain pattern that's underneath, okay? So it kind of just depends on the application. Usually you're going to see the more solid colors used for exterior applications. So if you have a special type of exterior stain for like a fence or a deck or something like that, typically that's when you would use a solid color stain to just block out all the wood grain of the cheap quality wood species, all right? So that's going to be it for this module. Again, it wasn't too heavy, pretty light, and a lot of it should have been review. So make sure you are reading through the reading that I provided. The reading goes a little bit more in depth and it covers a few more topics too, as well as plastic laminates and solid surfacing for millwork. I didn't touch on those in this lecture because those are going to be really heavily covered within your Methods and Materials 2 class. So that class focuses entirely on interior finishes, and I felt like it was better to just leave that for that class. But if you want to read about those and sort of get a head start on that class, that is perfectly fine. But make sure you're looking through the reading and understanding everything that I've talked about here in this lecture. And if you need anything, please reach out and I will help you.